Hey folks, and welcome back. In today's lecture, we're going to talk about variables and constants. One of these changes, one of them stays the same. So let's start off and talk about what a variable is. When you're writing computer code, you will sometimes need to store information in the program. And so a variable is used to hold a piece of information. Each variable can hold one thing. If you need to store more than one thing in your code, you would store them in multiple variables. Maybe you'd have 2 or 3 variables. So when you think about a variable, what you want to think about is a bucket. Typically, when you have a bucket, it's used to store one thing. So for example, maybe the bucket is collecting rainwater. So it's storing rainwater. So the type of stuff that's being stored in there is rainwater. The value that you're storing in there would be the amount of rainwater. And this is a bit of a stretch, but maybe you name that bucket the rainwater bucket because it's storing rainwater. So each variable can store one thing. A variable will have a name and it will have a value. So if we were storing information about me in a program, you might want to store my name, you might want to store my KSU ID, and you might want to store how many classes I'm teaching. So I might have 3 variables. One of them would probably be called KSU ID, and it would be equal to my KSU ID, 000 whatever number. The next variable will be called name, and that would probably be equal to Enda Sullivan. And the next variable would be how many classes I'm teaching. So maybe that one will be called number of classes or number of classes I'm teaching. And it would right now be equal to 3 because I'm teaching 3 classes. So a variable has a name and it has a value. And you can have more than one variable in a program. All right. Each of your variables will be of a specific type. And this is back to the analogy with the buckets. So generally, you wouldn't mix, let's say you wanted to have concrete and rainwater, you wouldn't tend to mix the two of those together in one bucket. You would have one bucket that's for the concrete and a separate bucket that's for the rainwater. And so you're going to make different types of variables. When you create a variable, you're going to specify which type of information it can hold. So generally speaking, there is the ability to hold a number, the ability to hold a character, where a character would be any number or letter on your keyboard. There would be the ability to hold a string. We kind of talked about that in the last lecture where we saw a system without a print line hi, and then hi was a string. And there's also another type called a Boolean, which we'll look at here in a minute as well. As the name suggests, the values can vary. When you create a variable called name, you can set it equal to Enda, and then later on you can change it to Jane, or you can change it to Fred, or you can change it to Paul, if that person changes name. And likewise, number of classes that I'm teaching might vary from semester to semester. So maybe it's 3 right now, maybe next semester I'm teaching 4, or I'm teaching 2. So a variable can change. However, the type of information it holds cannot change. So for example, number of classes I'm teaching will be declared as a type number because I'm holding a number in there, and I wouldn't be able to say number of classes I'm teaching is equal to Enda because that doesn't make any sense. So once you specify that a variable is of a particular type, it has to be always of that type. And again, the types are going to be numbers or characters or strings or Booleans, which we'll see each of those one at a time. So let's make our first variable. So if we wanted to make a variable that stored a number, we would do something like this. We would write int x. Now you might say, int, where'd you get int from? Well, int is short for integer. And in the Java language, a number that doesn't have a decimal point in it is generally considered to be an integer. Now, it actually turns out there's multiple different types of integers, which we're going to get into a little bit later. But for right now, and honestly, for the most part, if you're going to store a number in Java, you'll tend to use int. It's the most common one that you will want to use. So int, as I say, holds a number. So now that you have created a variable, now that you've declared the variable, you're able to assign it a value. And so now in your code, you could say x equals to 7. And that means that x is now equal to 7 until you change it. So because it's a variable, you could come along later and say x is equal to 9, and now it's equal to 9. But in between, it was equal to 7 until you changed it to 9. So it's a place that you can store information, and then you can look at it later on to see what the current value is as you run through your code. And you'll see how this will be very useful in a few moments. But let's go into a little bit more detail on this. I mentioned that each program can have more than one variable. As a matter of fact, it's quite common that you will have lots of variables. So if I was trying to describe a cube in my code, like a Rubik's Cube or some kind of a cube, I would need to remember at least 3 things about the cube. I'd need to know its height, its length, and its width. Now, if it's purely a cube, then okay, they're all the same number. But if it's any other kind of 3-dimensional shape, it could have a different length from a different width from a different height. So 3 variables is a very distinct possibility. The next thing to say is that when you declare a variable, you can either do it in 2 statements or you can do it in 1. So both of these are the same. And what I mean by that is this block of code here is actually the same as this block of code. They will both accomplish the same thing. In the case of the first one, I have 2 different statements. The first one is what's called a declaration. All right. And what I'm doing here is I'm creating a variable called x. It's of type integer. I have declared that there is now a variable called x. The second one is the assignment or the initialization. And that's because I'm assigning to it the number 7. And again, it will remain 7 until I change it. But it's possible to take both of those statements and combine them into a single statement, which is what's happening here. So the declaration int x is there at the beginning, and the initialization equals 7 is right there at the end. Sometimes you'll do it one way, sometimes you'll do it the other way. It's not that one of these is correct and the other one is wrong. They're both correct. It's just that sometimes you'll want to initialize it and declare it in the same place, and sometimes you'll want to declare it and initialize it or set its value in 2 separate places. So it's possible to do it either way, and this works on all variable types. All right. So next up, we have initializing a variable. When you declare a variable, when you create one, when you say int x, you really should always go ahead and set it to a value. Even if you don't really know what value it's going to be eventually, you should start it off as a known good value. Java is nice, and it generally sets all things to a reasonable starting position, so it sets all numbers to 0 to start with. But it doesn't like doing that, and sometimes you'll get a compile error where it'll say something like, you're attempting to use an uninitialized variable. And that's just Java's way of saying, you declared a variable, but you didn't put a value into it, and now you're trying to use that in a mathematical formula, and while that is technically maybe okay, you probably should have initialized it to whatever value you meant it to be. And so when you create a variable, you're probably going to want to do this single statement kind of thing where you're initializing it and declaring it all in one line. So you're probably going to want to get in the habit of doing both of those things together. Now, you might say, what on earth is long? You mentioned integer was how you store numbers, but now all of a sudden you're talking about something called long. Well, what's happening here is I'm declaring a variable. The variable's name is phone number, and I'm declaring it to be of type long. In the previous example, I was declaring it to be of type int. So what's the difference between an int and a long? And the answer is, well, it's just a different variable. Oops, that wasn't supposed to continue on. It's a different variable that has, or a different type of variable that can hold bigger numbers. As its name suggests, a long can hold a longer number than an int. And we'll get into some of the detail on that in just a few moments. All right, so let's talk about how you should name your variables. Every variable you create has to have a name. And honestly, you're going to find yourself scratching your head sometimes thinking, I don't know what to name this. What you should think about is, what is the variable's purpose? What is it going to hold? If it's going to hold my KSU ID, it should probably be named Enda's KSU ID. If it's going to hold your KSU ID, it should probably be called your name's KSU ID, and so on and so forth. When you name a variable, you're going to want to call it something useful. Don't just call it A, B, and C, X, Y, and Z. So like when you deal with algebra or most mathematics, it's not uncommon for you to have a variable X or Y or A where you just name it A, B, and C. Don't do that in code. You have the ability to use bigger variable names in code, and that will make it easier for you to understand what the variable is doing. So get in the habit of naming your variables something that makes sense about what they are storing. So there are a couple of rules that you have to follow. The first rule is the very first letter of your variable name has to be a letter. Technically, there are two other possibilities, but they're both frowned upon. So for the purposes of this class, you should always start your variables with a letter. And what I mean by that is A, B, C, D, some letter of the alphabet. After the first letter, you can have any number of letters, numbers, and underscores in your variable name. So you could have endas underscore KSU underscore ID, endas 7th KSU ID, anything you want as long as it's some combination of that. All right, so that's the first rule. You have to start with the letter, and you can only use letters, numbers, and underscores in your variable names. All right, so the second rule is that they can't contain spaces. So if you're going to create a variable name endas KSU ID, you cannot put spaces in the name. It can't be endas space KSU space ID. The variable name has to be all one word. So if you want there to be more than one word in there, the way that you cheat is you either do underscores, which is what's happening here. This is my variable name, and you can see that I used underscores to join the words together. Or the other alternative is something that's called camel case. In camel case, the first letter of the first word is lowercase, and then every other word the beginning letter of every other word is capitalized. And so you can see that you can read this. This is my variable name, even though it's a bunch of letters that are squished together. Underscores versus camel case, either one is fine. You can use either one, whatever makes you happy. You should just be aware that either of them is valid. Okay, so your variable name has to start with a letter. It cannot contain spaces, but you're welcome to use camel case or underscores. They are case sensitive. So if you have a variable called name and you have another variable called name, they are two separate variables. The capital N versus the lowercase n make them two completely separate variables. So be very careful when you name things that you name them consistently. This is part of the reason why that first letter should always be a lowercase letter. You notice that I did that in both of my examples here. That T is lowercase on that first one. And that just makes it more consistent that your first letter is always lowercase, therefore you don't have to remember that. And if you do the camel case the rest of the way, you shouldn't have a problem with finding two variables that are named the same thing. And then the final rule is they can't be a reserved word. Now, what is a reserved word? Any word that is part of the Java language is not allowed as a variable. And so, for example, you've seen the word int, you've seen the word long, and you've seen the word printline, and none of those are allowed. So what I mean by that is you can't make a variable called int. You can make a variable of type int, but you can't make a variable called int. I'm just going to demo that over here. This is Replit, and I mentioned in the last lecture how to use IntelliJ. For most of the examples that I'm going to do here, I'm going to do them in Replit. When you fire up Replit, you can hit Create New, and in this case, I clicked on Java. When you get the little window, you're going to pick Java out of the list. It's going to name it a random name. This one's going to be called Mobile Fixed Performance. Every time you make a new one, it's going to pick a random set of three words, and you can name it whatever you want. So if this is my CSE1300 example 1, you can absolutely name it like that. And then I hit Create. What's going to happen now is Replit is going to create me a new Replit, which is where I'm going to write my Java code, and it's going to give me this screen. Very much like IntelliJ, on the left-hand side we have all of the files, which again, I have one file and it's called main.java. In the middle window is where I actually write my code, and they go ahead and give me a skeleton, and you can see that that skeleton is identical to what I was getting over in IntelliJ. And then on the right-hand side, Replit gives you the output window, which is where you're going to see the output of your program. You can drag and drop between them. You just put your mouse over any one of those. You can move them around. So what I'm going to do is I'm going to create a variable that is int x. So that creates a variable called x. And when I run this code, which you do that by pressing the green button up on top, this is all going to compile, and the only thing it's going to do is it's going to print out hello world, because that's what the print line tells it to do. So my creation of int x really doesn't cause a problem. It doesn't really do anything. It just made a variable, and there's nothing in it, and life went on. All right, so now I'm going to do something with that x. So I'm going to say x is equal to 17. And I'm going to run this again. And you can see, again, the code is going to work. It's going to still print out hello world, and there's no actual problems in here. It is valid code. So once that is true, there we go, that worked correctly. I saw my hello world. Now I'm going to do a mistake. So I'm going to try and create a variable called long. So I said int long, semicolon. Just like I said int x up here, that was valid when I did it up here, but it's not valid when I do it down here. Why? Because long is not a valid variable name. It's very specifically not a valid variable name because long is a type. It's one of the reserved words. And we've seen that. I can create a variable that is of type long. So I'm going to change that to int y, and I'm going to make a long z. And now life is good. I have a variable called x that's an integer, a variable called y that's an integer, and a variable called z that is a long. But this is just to prove that you can't use any of the keywords in the Java language as a variable name. Some of them are tempting, but they won't work. So if you get something weird like that, it's probably that you named your variable something goofy. So those are the rules of creating a variable name. You are going to have to name variables all the time. Don't do x's and y's, which I know is what I just did in that very last example, but name them something that is more useful. All right, so let's talk about the different kinds of numbers in Java. Java differentiates between a number that has a decimal point and a number that doesn't have a decimal point. So what I mean by that is 7 versus 7.5. 7 has no decimal point, 7.5 does. And I think if you think about this for just a moment, you will realize the problem here. In the previous section earlier in this class, we learned how to convert something from binary to decimal and from decimal to binary. And so if I tell you to take decimal 7 and convert it to binary, you know that that comes out to 111. All right, cool. Convert decimal 7.5 into binary for me. Well, you can't. There's no way to represent 0.5. Binary, by its nature, is zeros and ones. There is no method to say half. So how do you encode 7.5 into binary? And the answer is, well, people didn't know how to do that for a very long time. And so eventually somebody came up with the idea of something called floating point. All right, so what floating point is the ability to convert a number into a number that has a decimal point into binary in such a way that you can actually, I cannot move this window. There we go. All right, I'm trying to get it out of the way. It will not let me move it higher than that point. Weird. Can I go lower? No, I cannot. Okay, awesome. Hey, there we go. And it puts it back. All right, system is called floating point numbers. So anytime that you have a number that has a decimal point, it has to be stored in what's called a floating point number. Because you cannot actually store 0.5, what the computer actually stores is a formula that evaluates back to 7.5. So think about it this way. If I said 15 divided by 2, that's 15 and 2, which are both decimals, or they're both full integers. They have no decimal point in them. But if you take 15 and divide it by 2, you'll get back to 7.5. So that's basically how floating point works. It remembers a formula, and then it approximates the number for you. The problem with that is every time it has to convert something into floating point or do any kind of math with floating point, it takes it a long time. Computers are really good at adding whole numbers. 7 plus 97, it can tell you in a heartbeat that that's 114 or 104, whatever it is. But if you ask it to do two floating point numbers, it's going to take it a little bit longer to do that because it has to do the approximations to get both of them and then do the math and then convert it back. So floating point is difficult for computers to do. They certainly all can do it, but it is not the way that computers like to work. All right, so how do we store numbers? Let's talk first about whole numbers, or numbers that do not have decimal points. We already saw briefly in the last slides the int type, and we also saw the long type. And let's talk about the difference between them, and let's also talk about the other two, which are byte and short. So all four of these things, byte, short, int, and long, are four separate ways of storing numbers in Java, specifically storing whole numbers, numbers that don't have a decimal point. They each have a different range of what they can store. The smallest one, they are listed in numerical order. The smallest one, byte, is only capable of storing values from -128 to 127. So if you want to store -129, you can't do it in a byte. If you want to store 130, you can't do it in a byte. So the number of things that you can use a byte for is pretty limited. It has to be a very small number. So for example, how many members are in your family? That probably fits in a byte, unless you have an incredibly large family. But something else like your phone number doesn't fit in a byte because your phone number has more than 3 digits, and it's certainly a number greater than 127. So bytes are really only useful for very small pieces of information. So then that brings us to the next one, which is a short. A short can store any number from -32,000 to +32,769. All right, so basically what's going on here is that shorts are bigger than bytes. They are smaller than ints, which are what we're going to talk about next, but they give you a much bigger range than a byte. Very specifically, a short is 2 bytes. A byte is 1 byte, and you might say, well, what is a byte? A byte is 8 bits. So when we talked in binary, we talked about 0, 1, 1, 1, 1, 1, 1, 1, where you had 8 characters in there. 0, 1, 1, 1, 1, 1, 1, 1. That's 8 characters. That is an 8-bit number, which is also known as a byte. 8 bits is 1 byte. So a byte can store from -128 to +127. A short, which is 2 bytes, so 16 bits, is able to store from -32,000 to +32,000. A int is going to be 4 bytes, and that's going to be able to store from -2.14 billion to +2.14 billion. It's a more specific number than that, but that's the approximation. And longs are able to store numbers that are greater than 2.14 billion all the way up to 9 quadrillion. All right, so that's a very large number. So if you're trying to, or quintillions, sorry. So if you're trying to store a number that's huge, you're going to need a long. Most of the time, you're going to use an int for everything else. And you might be wondering to yourself, why did they make this so complicated? Why isn't there just one thing that stores number? And wouldn't that have been just easier for everybody? And the answer is yes, but there's a reason for this, and we'll come back to that in just a moment. All right, so next up, let's talk about storing numbers that have decimals in them. So there are 2 ways of storing things that have numbers, or that have decimal points. The first is called float, and the second is called double. And again, it boils down to how big a number you're trying to store. The float can hold up to 7 digits of precision, whereas a double can hold up to 16 digits of precision. So if you're trying to store the number 7.0000001, then you can do that in a float. But if you need to store this, you would need to do that in a double. So doubles are what you're going to use most of the time because they have the advantage that they're able to store bigger things. So in general, if you're choosing one of these for each of them, you'll often use int for integers, and you'll often use double for storing floating point numbers. All right, so we have 2 more types that we want to look at next. We have characters. So a character can store 1 character on the keyboard. So A, B, C, D, E, F. It could also be 1, 2, 3, 4, 5, 6, 7, because those are characters as well. It could also be an @ sign, a pound sign, a dollar sign, a percent sign, parentheses, curly braces, plus, equals, anything like that. Even a space, all of those are characters. So basically anything you can type on your keyboard is a character. And so you might declare a character X, and so this is the type char, this is the name of the variable X, and this is the value that you're assigning to it. Now there's a couple of things to notice about the value that you're assigning. The first is that it will always have single quotes around it. Now, remember earlier when we were looking at the print line statement, in the print line statement we were using double quotes, and I mentioned that that was a string. Double quotes imply string, single quotes imply characters. So if you're dealing with a character, it's going to be a single quote. It has to be a single quote. You can't use double quotes or it won't work. All right, and as I mentioned, you can hold any character from the keyboard. That would be a space right here when there is nothing in between the single quotes. All right. The last of the types is going to be Boolean. All right, now this one's a weird one as well. Boolean can only hold 2 possible values. The first value is true, and the second value is false. It's useful anytime that you're dealing with something that has only two possible choices. And so, for example, is it raining? It either is raining or it's not raining. There's no in between. So it's a Boolean. So you would say something like Boolean is raining, and that would either be true or false. I just noticed that there was a typo in that slide, so I just corrected it. Apologies on that. When you say is raining equals true, there should not be double quotes around it. I don't know why they were there. So Boolean is raining equals true is how you would specify true or false. If you put double quotes around it, it's a string, and that doesn't work for a Boolean. So there cannot be double quotes around it. All right, so anytime that you're dealing with something that only has two possible states, it's going to be a Boolean, and that's going to be true for a lot of stuff, like passing class. Are you passing this class? Either you are or you are not. Those are the only two possibilities, and so on and so on and so forth. So Booleans are very useful for things that are one thing or the other. All right, the next word that you need to be aware of is the word literal. Anytime that we use a value in the code, it's referred to as a literal. So let's take this example that we've looked at before. So we have int x equals 7. So there were three parts to this. The first part is we declared a variable called x. All right, so this is the variable name. The second part was the type. This right here is a type. And then the part that we haven't talked about is this 7 is actually called a literal. And it's called a literal because I literally typed the word 7 in there. All right, I know we all love the word literally because it's just a thing everybody says when we don't really mean literally. But I literally typed the word 7 in there. And I actually really mean that I literally typed the word 7 in there. All right, so anytime that you're putting a value directly into your code, it's a literal. So int x equals 7, the 7 is a literal. String name equals enda, and we're going to see that in just a moment. Enda is a literal, in double quotes. Boolean is raining equal true. True would sort of be a literal, but that's kind of a weird one. So in general, anytime that you're putting a specific value in there, it is a literal. All right, and so that brings us to a magical word, which is primitive versus complex. Most programming languages have a set of primitive data types. The primitive data types are the basic building blocks that the language understands. If you're not using a primitive one, you're using a complex one, which is usually a combination of some of the primitive ones. And so you can build building blocks on top of each other. If you think of Lego, there are 7, in this case, there are 8 primitive Lego blocks. And then every structure that you make is going to be made out of those 8 blocks. And so you've already seen the 8 blocks, but we'll run through them again real quick. We had byte, short, int, and long, which were the 4 that hold integer numbers that don't have a decimal point. Then we had float and double, which are ones that hold numbers that do have a decimal point or floating point numbers. Even double is considered a floating point, even though its name isn't float. I know that's really annoying. But float and double are floating point. Byte, short, int, and long are integer types. And then char stores a character, and Boolean stores a Boolean. Anything that is not one of those 8 is considered a complex data type. And you've seen one of those so far, which is string. String is a complex data type. And if you think about it for just a moment, you'll realize that a string is really a bunch of characters that are meshed together. A character can only hold one character, whereas a string can hold a string of characters together, as if you are tying them together with little strings. So that's where that comes from. It is important that you remember the 8 primitive types. This is a question that is asked very often in interviews. It's a question that's asked on tests in this class and the later classes. So you just need to memorize the 8 primitive types. They come up all the time, weirdly enough. All right. So that brings us to a variable to hold a name. All right. So in the past, when I did the system.out.println, I printed hi. And I told you that that was a string. Let me zip over to my Replit window here real quick. And I'm going to delete all of this stuff that I had previously typed in here. And I'm going to get back to the original code that I had, which was, this was the skeleton that Replit originally gave me. And I mentioned that Replit does something that IntelliJ doesn't, which is it puts in a system.out.println that simply prints out hello world. I also mentioned when we were dealing with that this is color-coded differently to everything else in there. And again, in IntelliJ, it happened to pick brown for strings, but it is highlighting them as a different color to show that they're a string. So I could actually create a variable that is of type string by saying string name equals enda. Now, a couple of things to notice there. The word string is capitalized. You have to put a capital S on front of it. All the rest is lowercase. The variable name is enda, and the thing that I assigned to it is the string enda. And again, when it's a string, you have to put double quotes around it. By comparison, if I was to make a character first initial, I would have to do single quotes around that. So single quotes for characters, double quotes for strings. Just a rule you have to remember. All right, so that's how you declare a primitive data type, char, and this is how you declare a complex data type. It works exactly the same way. There is a type, a variable name, and then I initialized it to enda. And just like before, I absolutely could do it in 2 steps. I could say, I could say string enda, and then I could say name equals enda as 2 separate lines, and that would work just fine. So just be aware of the fact that that can be done in 1 line or it can be done in 2 lines either, regardless of whether it's primitive or whether it is complex. So that's creating a complex data type. All right, so next up we have an uncooperative computer. Let's see where we go here. All right, so why do we care about all of these types? Why do they have 8 primitives and then 1 complex that we've already seen? Why couldn't they have all just agreed, especially for the ones that don't have decimal points? Shouldn't everything just be a long and then we don't have to ever think about it? Why would we want to ever use a byte or a short or an int when we have long that seems to do everything they do plus some more? Well, the answer is that it takes up more memory to store a number when you store it as a long than it does to store it as an int. And you might say, okay, do I care? And the answer for right now in this class is honestly, no, you don't. For CSE 1300 and for when you're getting started in programming, we're not teaching you how to optimize your code to be very efficient. And your computer probably has more than enough memory in it that a long versus an int is not going to make any difference. However, as you write more bigger complex code, if you were to use longs for everything, and let's imagine you ended up with 5,000 variables, then I think all of a sudden you could see that would take up a lot more space. So it is important, it's just not important right now. So just as an example, a long takes up 8 bytes. So to be clear, what that means is every time that you store a long, it's going to take up 8 bytes times 8 bits, which means it takes up 64 bits. If you have 5,000 variables, then all of a sudden it's taking up 320,000 bits. And even when you divide that back into bytes, it's 40,000 bytes, or to phrase that differently, it's 40 kilobytes. So it's using up 40 kilobytes of RAM in order to store your 5,000 longs. And again, that doesn't sound like an awful lot. Let's get crazy. Let's say that you have 64 bits for each long and you need to store 1 million of them. And that's not a completely unreasonable thing. There's more than 1 million people in Georgia. If you were storing a phone number for everybody in Georgia, you would be storing 10 million. So times 1 million, all of a sudden you're at 6.4 million. And if I divide that by 8 to get back to bytes, I'm storing 8 megabytes, because there's 1 million here, 8 megabytes of information. So that actually corresponds to 8 megs of RAM is being used. And your computer probably has 8 gigs of RAM, which is 8,000 megs. But you're using 8 of them just to store these phone numbers. And again, you can start to see that that's starting to add up. And I grant you, for everything that you're going to do in this class, for everything that you're going to do in the beginning of your programming career, none of this is really going to matter. You'd be able to store everything as longs and really never run into a problem. But over time, memory and utilization of memory will cause your code to run slower the more memory that you're using up. And so you would want to be conscious of the fact that you need to be aware of how much RAM you're using at some point down the road. Okay, so for today, you're probably going to use ints for pretty much everything, unless it's a bit number that's going to get greater than 2 billion, in which case you'll use a long. And you're probably going to use doubles for pretty much everything that is a floating point number. For chars, you're going to use a char, and for Boolean, you're going to use a Boolean. There are no choices there. So it's ints, doubles, chars, and Booleans that you'll use the most. But having said that, in test questions, in quiz questions, and in interview questions, if you were to take an interview for a programming job, they will absolutely ask you what the differences are between the ints, shorts, bytes, and longs, and between the floats and doubles. So it is something you need to understand, but it's not going to materially affect your ability to code today. All right, so the next topic, we've so far talked about variables. Everything that I've talked about since the beginning of this video, which seems like it was 4 hours ago, is a variable. Next up, we're going to start talking about constants. So a constant is a sort of like a variable, except it can't be changed. Once you declare what its value is, it is set at that value forevermore, and you cannot change it. And you might say, well, why would I ever want to do that? And the reason is because sometimes you have things that you don't ever want to change in a piece of code. So for example, if I'm building a registration system for this class, well, it turns out there's about 130 seats in the lecture hall that we're teaching in. So it would be very important to not let more than 130 people register for the class. So maybe I would put a max students equal to 130. Okay, so how do you go about declaring a constant? Much like variables, they have 3 things. They're going to have a type, they're going to have a constant name, a value, and the thing that makes them constant is this word final out at the front. All right, so let's go through these one more time. The word final is how you make something constant in Java. You declare it as final, and then as the name suggests, it can never be changed again. Just like variables, constants must have a type, and in this case it's int. The variable name, there's a convention that you make the variable name all capital letters. Now let me be clear, when I say it's a convention, what I mean is that it's something that people tend to do. It just makes it clear that this is a variable later on in your code. But it would work whether you did this or not. If you call it lowercase max students, it would still work. So it's not a rule insofar as it's a syntax error that the compiler would tell you, no, I can't do that. It will allow you to do it either way, but it's a convention that you should follow because all programmers follow it. So generally when you declare a constant, you're going to want to use all capital letters. The other rule is you have to actually assign it a value at the moment that you declare it. And if you think about that for a moment, I think you will understand why. I certainly can't come back and change the value later, so that kind of proves the point that I have to set it at the very beginning. So if I come back in here and I get back to the point where I can type again, there we go. So I'm going to say final int max students equals 130, and I'm going to compile that and run it, and life should be good. I'm not going to get any kinds of problems from that. But if I were to try and do that in 2 separate statements, so you can see that worked, I'm going to change this to that, where it's 2 separate lines. Now all of a sudden it's not going to work. And the reason is because it's final. I cannot change it. And that's exactly what I'm trying to do here on line 5. I'm trying to change it. And of course it let me do it for some strange reason. It shouldn't have let me do that. I don't know why it's letting me do that. Either way, don't do that. Do it all in one line. All right. So constants need to be declared and initialized all on the same line. Okay. So we've talked about variables and we've talked about constants. What can we do with either of these? And the answer is we can put them together and we can use them inside of a print statement. It's not terribly exciting, but let's take a look at what we can do here. So I'm going to go back to my code and I'm going to get rid of this because it really should not have let me do that. I'm a bit weirded out by the fact that it did. Also, I don't know why my key shortcuts are not working, which is why I keep typing random letters. All right. So what we're going to do is I'm going to declare a string name equals enda. And then in my print statement, instead of printing out the literal string hello world, I'm instead going to print out name. Okay, now this is different than what we've seen before. The name I did not put in double quotes. As a matter of fact, it's just sitting there without double quotes. When I run this, it's no longer going to say hello world, it's now going to say enda. And you can see there it is right there, it said enda. So why did it say enda? Well, because I told it to print out name. Now, if I put double quotes around this, what's it going to actually print? Oh, goodness, there we go. Well, this time I told it I wanted to literally print name. So it literally prints name. When you put double quotes around a string, you're asking for it to print a literal. When I take away these double quotes, it's not that I am now changing it from a... what I'm doing is I'm asking it to use the variable called name and print out its value. So what happens here is it takes a look at the variable name, and you can see when I double-clicked on that here in IntelliJ, it highlights the corresponding definition up above, and it shows me that it is currently set to enda. And since this is a variable, I could change it multiple times in here. So name is equal to Janet. And now when I run my code, it'll print out Janet instead of printing out enda. And that's because initially name was set to enda, but then name was changed to Janet, and then when I asked it to print, I got Janet. As a matter of fact, I could take this statement and I could copy it and I could paste it above here, and I would get yes. Okay, there we go. The first print statement on line 5 is going to print out enda. The second print statement on line 9 is going to print out Janet. Now, I need you to realize something here that's really interesting about all this. Line 5 and line 8, as they are currently sitting in the window, are identical lines of code. They both say system.out.println name. But the value of name changed between line 5 and line 8 because on line 7 I changed the value of name. So this is a circumstance which you're going to see a lot where the code is using a variable, and then the variable can be changed as you go through the code. And so you may not necessarily know what the print statement is going to actually print out because it's dependent on the current value of name. And you're going to see how this is more and more useful as we go on later on. And this would work regardless of whether they're strings or something else. So for example, if I change this to an integer and I set it equal to 7, and then down here I set it equal to 9, you're going to see that it's going to print out 7, and then it's going to print out 9. It works regardless of whether those are integers or strings or anything else. They are variables, therefore I'm able to print them out. All right, so putting them back to strings and changing this back to enda like it was a moment ago, and then changing the string to, oh, by the way, you can see that IntelliJ underlined that 9 in red. Can you figure out why? It's because string is a name, name is a string, and that's a string, but this is not a string. 9 is not a string, it's an integer. Now, if I'd put double quotes around it, it would be okay with it because then it's a string again. It just happens to be a string of the number 9. So that would be okay, but you can't randomly decide, now I'm going to put a number in here. Because it's declared to be a string, it can only hold a string. So you don't just get to change that later on in the code. You can change it to any other string, as long as you can spell, but you can't change it to another type. All right, so I've set the name equal to enda, then I set the name equal to Janet. I printed both of them out, and it will print again. All right, so what happens if I wanted it to say, hello, my name is enda, instead of just saying enda? Well, I can mix and match inside of this print statement both types of things that I've seen. So I've seen a string literal, which is what that looked like. And if I were to just do that, and then on a separate line, let me put the closing parentheses there, and then let's put another copy of system.out with the name there, then it's going to print out, hello, my name is enda. And right now they're going to appear on two separate lines. Hello, my name is on the first line, and enda is on the second line. But we've already learned I could fix that by coming in here and taking out the ln, so that it's system.out.print, hello, my name is, and then print line enda. So that's going to print out the first big long string that says hello, my name is, and then the second one prints out enda. Now you'll notice that there's no space in there, and that's because there is no space in here. I told it to print this, and then immediately after that S, I told it to print out enda. And since there's no space in the string enda, and there's no space there, I don't get a space. If I want a space, I need to add it in like that. And now when I run it, you're going to see a space, hello, my name is enda. So that's using two different print statements. One of them is printing out a string literal, and the other one is printing out a string variable so that I can see information coming out. And I can actually combine these into one line. So I can say system.out.println, hello, why do I keep putting a W? My name is, and then after that first string, I can tell it I wanted to add in the value of name. All right, and I'm going to run this, and you're going to actually see hello, my name is enda twice, once from this, and then another time from this, and then you're going to see Janet. So those two lines, this turns out to be the exact same as line 8. In line 8, I did it in one line. In lines 5 and 6, I did it in 2 lines. So let's talk about this plus operator. So what does the plus operator do with a string? It allows me to concatenate two strings together, and that is just to push two strings together, to join them together effectively. And you can actually do it more than once. So I could say, all right, and so now what I'm telling it to print is, hello, my name is, whatever the value of name is, followed by a period, followed by 2 spaces, followed by thanks for visiting. And apparently I forgot the semicolon. I put in an extra parenthesis. All right, so that was me. But now I'm going to get, hello, my name is enda, thanks for visiting, from this line. All right, so you can do this as many times as you want, where you can push pieces of strings together along with variables or constants to fill information in. And so I could absolutely use a constant in here as well. Let's do that. So final int max class equals 130. And then down here, I'm going to add in max class. I don't know why I'm printing 30 at the end, but I just wanted to show you that it is possible to add that in there. And it'll say, thanks for visiting 130. And I did the extra parenthesis again. Actually, that's my IDE trying to help me when it doesn't need to help me. I just keep ending up with an extra parenthesis over there. I'm just going to move this window over a little more so you can see it. There was 2 parentheses there a moment ago, which there's not supposed to be. All right, so if I run that again, we get thanks for visiting and then 130. There's the value of that. So you can mix string literals, which are just strings that are in double quotes with literal information in them, variables, which don't have double quotes around them, constants, which don't have double quotes around them. You only put the double quotes around string literals, and the variables can be of any of the types that we've talked about: integers, floats, doubles, chars, even booleans. That's kind of weird, but it is possible. Constants, and so on and so forth. All right. This was adding strings together. That's what I just did there. And okay, so we've one last topic to talk about. Let's imagine that I wanted, I'm just going to delete all of this. Actually, I'll just leave it there. I'll just put new code up above. I'm going to create a new string, and in the string, I'm going to call it sentence. And I'm going to say, Enda said, hi. Now, the problem that this is creating is, I'm just going to ask it to print the sentence. Goodness. There we go. Sorry, they've updated and it's working slightly differently than it used to. Okay, so you can see that Java is not happy here. Replit has underlined from here to here, and you might want to be able to think about that for just a moment to see what might be wrong with that. So I mentioned that a string literal is defined as a set of characters that are enclosed in double quotes. And by that definition, this string begins and ends in the part that I have highlighted in blue. But that's not what I meant. What I meant is that inside the string, I wanted to use a double quote. And the problem is I can't use a double quote inside a string because double quote is what delineates the beginning and end of a string. So there has to be a way to solve this, and there is. It's called an escape character. On the off chance that you need to use a character that has particular meaning to Java inside a string, you're going to use a slash on front of the character to say, this doesn't mean what you think it means, this is just literally trying to print out a double quote. So now, this is actually a string that begins and ends there, and you can see that Java is happy with it. The internal double quotes will show up when I print it, so when I hit run on this, since it's asked to print out sentence, I'm going to get Enda said hi, and there's going to be double quotes around the hi. They're literally getting printed out. And that's because I told it that those double quotes don't have the normal meaning, which is the end of a string or the beginning of a string. All right, so this is called an escape sequence. Anytime that you need to tell the computer that something has a specific meaning, you're going to use an escape sequence. And in the slides, there's a handy dandy little chart that shows you the most common ones that you're going to have. This is the one that I just did, the double quote, and you can see it was slash double quote. Sometimes you might need to do a single quote, and that works the same way, slash single quote. Since slash has a particular meaning, which is ignore the meaning of the next character, if you were trying to put a slash in the middle of a string, you can't do that because it would think that the next character has special meaning. So to make that work, you have to do two slashes. So for example, if I was going to say Endo wants to print slash slash, and that's what I was trying to actually print, when I run this code, I can either have one quote or two. Sorry, there we go. When I run this code, this is going to have a problem. The first slash means ignore the meaning of the second slash, and so what printed out was I only got one slash. So if I actually wanted two slashes, I would weirdly have to do slash 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 slash, because the first slash says this one doesn't have special meaning, and the third slash says that one doesn't have special meaning, and so I get my two slashes. So that's a weird one. All right, so if you're trying to print out double quotes in the middle of a string, you're going to do slash double quote. That's a pretty common one. Slash single quote happens. The double slash is one that I'm going to tell you this, you're going to forget it, and in about 2 months, you're going to need it one day, and all of a sudden, you're going to remember this slide is here. So there you go. The other most common one is slash n. Slash n is a new line character, and let me explain what that does. So I'm going to put a slash n in the middle of this sentence here, and then I'm going to take out all these crazy slashes at the back because, well, they'll be confusing. So remember I used a system.out.println to print sentence, which sentence is equal to that. What you'll get is enda, and then on the next line you'll get space wants to print. And the reason for that is because the carriage return is a new line. It's the equivalent of pressing enter in the middle of a string. So if you want the string to have a enter in the middle of it, you use a slash n. And you might be thinking, wait a minute, wasn't that the difference between a print and a print line? Yes. So in actuality, you could never use a print line in your life and simply just use prints and put the slash n's in there yourself, and that would work just the same. So sometimes it's nice to be able to do it in the middle of a string, like here where I wanted it particularly in that position in the string. So rather than having to do a print line and then another print line, I can just put the slash n in there. So out of this slide, the three most common things that you're going to want are that new line, the double quotes, and the single quotes. A tab is occasionally useful if you want to indent information. A tab will move it in about 8 spaces usually. The backslash is occasionally useful. The carriage return versus new line, usually you'll just always use slash n for new line. Don't worry about the fact that carriage return is also listed here as slash or. In some operating systems, it means one, and in the other, it means the other. This is way beyond the scope of where we are right now. And the backspace is a weird one, but you can technically hit the backspace key in a string by typing a slash b. Not something you're probably going to want to do anytime soon, but it is possible. All right, so that is the end of today's lecture, and we were just talking about how to use escape sequences, and here we have a final example where I'm system.out.printing. So this is a print, so it's not going to do a carriage return at the end. It prints hi, and then a tab, because of the slash t, that's going to give you a tab. And you can see in here in the output, there's extra spaces in here because of that tab. My name is slash double quote, So I get a literal double quote, Sean slash double quote, and there's my literal double quote, slash n, which causes a carriage return. So we go back to the beginning of the next line, and then goodbye. So that just shows you how you can use those literals or those escape characters inside of a string or a print statement or anything else like that. Okay, so in today's lecture, we have talked about variables, we've talked about constants, we have talked about prints and print lines, we've talked about concatenating strings, which was with that plus sign to push things together, and we've talked about all the different types of variables such as ints, chars, doubles, floats, shorts, longs, bytes, and booleans was the other type. That was the primitive types. And then also the only complex type you've seen so far is a string. So that completes today's lecture and this section, and we will see you in the